everybody, and welcome to our lesson number 3 on our assessment item. What we're looking at today is how to write the evaluation of your evidence. So we're going to quickly, I'll go through the learning intention success criteria, we'll talk about what you should have had done, and we'll quickly do a recap on what we've looked at so far as our examples. So, learning intentions. Students will be able to analyze and evaluate the evidence they have referenced in their report to assess the reliability and the validity of the evidence. Reliability, looking at the type of evidence that you have used and how it was collected. The validity is how well it answers your research question that you have written. Okay, so that's your learning intention success criteria. I have written the evaluation and commented on the reliability of the evidence collected and the validity of the evidence in terms of answering and being evidence for answering the research question. Completed tasks. You should have a research question, definitely. You should have found evidence to support it or reject it one way or another. You need to have evidence to answer it. Number 3, you should have written about the evidence already. Quick recap on what our sample is and our sample that we're creating as we go, or note-taking or discussing how we would answer it using that scenario. So the fancy sample that we have is the one with the claim that says human evolution is still occurring. The research question that was created out of it was, is the prevalence of lactose intolerance in Finland linked to the practice of domesticating cattle for dairy purposes? And the evidence that they had collected was related to an indigenous population in Finland called the Sami, and they referenced the fact that the Sami used to use reindeer or have reindeer and drink reindeer milk, and that reindeer milk was low in lactose. And the Finns used to keep cattle, and they used to drink cow milk, and therefore it was high in lactose. So their first piece of evidence that they had was that they used to compare the milks. So they looked at the difference in the lactose levels between the two types of milks. And then they compared the lactose persistence alleles that are found in the Sami population, which showed a low frequency of that allele, and then in the Finn population, which showed a high frequency of the lactose persistence alleles. So suggesting after they'd done their summary that the Finns expressed a higher ratio of lactose persistence, meaning that they tolerated lactose well because they had been farming cattle for years, whereas the Sami had a lower frequency of the lactose persistent allele because they have been using or drinking reindeer as part of their history. So what we're going to have a look at now, and I'm going to try not to overwhelm you, so I'll show you a piece at a time, and we might just cover up that side, is how we would write about this or evaluate this evidence. We're going to first look at the sample. I'll quickly brief over this, and we'll look at how the sample addresses each of these, and then we'll do our own one as well. So in the sample, we're going to find that it evaluates the limitations of the evidence. So you want to really be referring to nearly all the pieces of evidence. This one's got quite a few, but your one might only have one, so you'll definitely comment on limitations related to that evidence. In order to do that, you will need to comment on the reliability of the evidence. In terms of reliability, this is really easily answered in a couple of steps. Is there more than one source that suggests or supports the same as what your evidence that you've used has? If your evidence is the only one that you have found, it's possible that it's not really lacking, or it's not been replicated, and it's lacking the support and the general notion that more than just that one person believes it. So that's the first thing. And the second thing was the evidence collected using good scientific techniques of fair testing, repetition, spelled that one interesting, repetition, and is it a good sample size, etc. So anything that you see that might be incorrect in the way that it is being tested and collected. Then we need to evaluate the quality of the evidence that is presented. So is there information that is possibly silenced, left out, that may suggest an alternative outcome? Is there something that's missing here? Is there another thing that's happening in the background that hasn't been taken into account? This one does cross over a little bit with this one up here, but if you're commenting on it, you'll get the marks for it no matter which section it's in. And how well does the evidence answer the research question? Before I go into here, there's one thing that's just popped into my mind about this one. What was the purpose of it? So often we'll find research that is done in terms of paid for. It's being paid for by a company that is selling something that is possibly questionable. So something that's popping into mind, and I am going to quickly preface this with, I have no idea, but I'm making this scenario up, but it's something that is relatable and possibly real world, is, for example, cigarettes and vaping, and so the difference between the two. If you were a company owner or, of a vaping product, you might go and pay a scientist to conduct research on your product to encourage people and tell them that it's safe. But the research that you have done, or the way in which you've tested, might have been tested strategically in order to make it sound safer than what it is. So you may test the effects of vaping on respiratory disease, or actually let's change it. Let's say on physical fitness at that point in time. So you might compare it to cigarettes and say, well, cigarettes have a much greater issue or affect your physical fitness or lung capacity more than what vaping does. And so that might be where you test it. But what you may not be testing then is the long-term issues that might be linked still to cancer and lung cancer. So I'm going to add in here purpose. So what was the purpose of the testing? It's relevant to some things, not to all things, but it's a good thing to keep an eye out on. The next piece then that we're going to look at is, how well does the evidence answer your research question? Does it have a clear-cut cause-effect balance? So in this one here with the situation with the cattle, we might be looking at, so is that the only reason that there might be a change in the allele frequencies? Is there nothing else that's possibly coming into play? So we'll have a look at the sample before we go into any more detail, and we'll pick up these bits as we go. So actually, what I might quickly highlight with you is also these sections here. So your marks and where they come from, what you are looking for, not so much here, is, so you've got a grading system here, so thorough and appropriate identification of limitations of evidence. So that one there is what we're going to be assessing in this section, as well as insightful discussion of quality of evidence. So this one here, when you have a look at your criteria sheet, insightful discussion of the quality of evidence, extrapolation of credible findings of the research claim, and that's it for this section here. More so this one than anything else though. So the insightful discussion of the quality of evidence. So those two criteria are what we are looking at this section right here. Okay, so we'll skip past that one. That's just a piece of the evidence. Here we go. Let's have a look at the evaluation. So keep in mind that their evidence was the breakdown of what's found in the milk. So comparing cows with 5% lactose and reindeer with 2.4% lactose to, and also comparing the allele frequencies of lactase persistence between the Finns and the Sami. So let's have a look. I apologize for it being rather small, but I'll read it to you anyway. I don't think I have a larger one. No. Okay, so there are issues associated with the evidence presented, however. Hagelin was the only source of information about the lactose percentages in reindeer milk. It could be assumed that this is because it is very cold in Finland and it takes 2 people to milk a reindeer to get 2 cups of milk. Maybe scientists are not interested in these conditions and don't really want to find out more about reindeer. Consequently, only one source of evidence limits the reliability of this information. So in this one here, the sample has looked at the first piece of evidence. They've also identified with this one that it is the only source. the only source of evidence that supports that information, and therefore it limits the reliability. No matter how simple it is to test reindeer milk for lactose concentrations compared to cow milk, the fact that there is only one source and they haven't found another one or a second source to back it up does mean it's a limitation of the evidence. Can you back this up inside your evidence? You absolutely can, and you don't have to throw that information in. You just need to reference it with inside that piece, that analysis or evidence when you've written about your evidence. The next one, also the sample size N in table 2 is not indicative of the finished population. The genetic survey of 1,876 Finns is only about 3.5% of the population, and 60 of the Sami is only 1.3%. This is not the entire population for either group, so therefore cannot really be used to make significant conclusions. Also, only one source of evidence was found, which again limits the reliability. So now they're looking at their second piece of evidence. So they are assessing each piece of evidence as they go. So second piece. They have commented on the sample size. And they have referred to the reliability of the evidence because of the sample size. And so if we have a look over here at our list that we had, they've commented on the reliability of the evidence. They've talked about how many sources have support them in both one. So that one there they have done. They have spoken about the testing technique in the sense that the sample size is rather small in this one in comparison. So they've done that one. And let's have a look at the rest of it. So the data in table 2 is also limited due to the testing process used to obtain the data. So they're referring to the processes. So again, we're looking at this one over here. Itten 2010 indicates that blood glucose and breath hydrogen tests have error rates associated with them. These are type 1 and type 2 errors. They also state that loss of lactase can be associated with gut trauma, not just the LP phenotype. In addition to this, the technique used to obtain the data in table 2 can only test for the alleles in the table. How do we know that more allele types don't exist? So in this section here, they have referenced and referred to the information that might suggest an alternative outcome. In other words, they're suggesting here that it's possible that gut trauma can change that, can also result or cause the loss of lactase. And so that's given you an alternative outcome or an alternative cause for the same outcome, as opposed to making it weakens that cause-effect relationship between the between saying that it's because of the milk that each group has been drinking in their history. So, well, what I'm going to quickly do is quickly summarize. They've looked at the two pieces of evidence, and they've looked at these two sections here where they've discussed the reliability of it. In this last one here, they've then looked at the quality of the evidence and how certain pieces of certain extra pieces of information, if provided, then bring these two pieces of evidence into question. So what has weakened it in general? Something that I'm not too impressed with here is the type 1 and 2 errors. They haven't actually explained them, and if they had explained and further linked them to how that would have affected the evidence, it would have strengthened this evaluation significantly. So affected the evidence. I'll put that in here as well. What else can I tell you about this one? Let's have a look. So they've found the alternative that could provide the same outcome. And they've also found a question here that will then open up the possibility of that the evidence is irrelevant to the research question. So definitely not a bad little paragraph about the quality of evidence. Moving on. So the data also doesn't take into account that the change in alleles between populations isn't just because of a strong genetic drift. Without further research to support how the Finns and Sami differ, it is difficult to comment on this. Therefore, this would be a plausible area of further research to find out more on. So in this one here, they're looking at, again, missing information. So what's being silenced? And what possibly suggesting what else needs to be looked at. What further research needs to be done? And the last bit, it should be noted that just because Daring and the LP alleles appear at similar times, it doesn't mean this is a causal relationship. It could simply be a strong correlation. This difference means that whilst the two variables correlate, it does not mean one thing caused the other. So that's what we're talking about here. This is our last dot point that we have, and it is looking at how well does the evidence answer the research question, cause-effect relationship. Even though there is quite a clear relationship there, we don't know that one thing caused the other thing. So that one there is our last one in here. So the cause-effect relationship. Okay, so that is the breakdown of our evaluation. Let's have a look at, let's go back to our sample and have a quick discussion about that, our lolly example, I should say. So our lolly example looked at whether or not lollies make people happy. And then we came up with I'll just bring up that sheet. We came up with the research question: does providing students at Chisholm Catholic College with jelly beans daily increase their productivity, evidenced by increasing their grade? So that was the research question that we were looking at. The piece of evidence that we then wrote about was this one here, where we had boys and girls, and we looked at the percentage grade change, and we saw that boys increased their grade by 6% and girls by 1% when they were given lollies daily. So now what we're going to do is we're going to evaluate or find possible issues or limitations related to this piece of evidence that has been so scientifically collected. Okay, so let's have a look. The first thing that we're going to check out is there more than one source of evidence that suggests or supports this? Unfortunately, this piece of evidence came from one teacher. One teacher, and that's all. That one teacher collected evidence from one class. So only one piece of evidence that supports this conclusion, so that is a limitation. What was the evidence collected using good scientific techniques, such as fair testing, repetition, and good sample size, etc. So the data was collected using some elements of fair testing. For example, the same students were used and the teacher was the same. However, different content was being taught and a different exam was had been administered. And it was one class only, so the sample size was quite small, and it doesn't account for the fact that students are constantly maturing. So if you test them with one test in term 1 versus term 2, they may have matured in between the two. They may favor certain content over others with previous exposure that's more relevant or relatable to them. So there's a number of different issues with the type of testing that was done. The next one is there information that is possibly silenced or left out that suggests an alternative outcome? Yeah, there is. For example, this one here, it's not accounting for maturity. We could find evidence that says that children will continuously mature and therefore be able to adapt to the testing situation of an exam, or learn more quickly once they're comfortable in a classroom for a period of time, or get to know how the teacher works. So we might find all of this information that might suggest that maybe the increase in grades is purely because the student is more comfortable in the classroom, knows the teacher and the expectations, and can work more productively. We don't know. Another thing that could be happening is we are unaware of other supporting programs that may be responsible for the increase in scores. So after term 1, perhaps the school implemented a new literacy program or numeracy program in which the students were working through for the entirety of term 1 and term 2 before they did their term 2 exam. Maybe that's what boosted scores for them in that term 2. It also doesn't state if the lollies were given as incentives or as food. So we now still don't understand why, whether it is the lollies and the increase in sugar that feeds the brain, for example, that is going to increase the scores for the students, or whether it's just the fact that they're working harder for the possibility of being given a lolly. And we don't know if the work was easier. So was it as simple as the teacher wrote an easier exam? And the last one is, how well does the evidence answer the research question? For example, a cause-effect link, is it strong? And I've written here, despite appearing to be solid supporting evidence, more would be needed to adequately answer this research question. So obviously a far more detailed explanation of the experiment, better planning of the experiment, and more repetitions of this experiment would be needed in order to make this substantial enough evidence to support the claim and the research question. So that there is the breakdown of our evaluation. To quickly summarize, you need to, for each piece of evidence, ensure that you've commented on the reliability by looking at the number of sources that say the same thing and how the evidence was collected. You then need to comment on the quality of the evidence by looking at what is missing, what may not have been researched or tied into this experiment or this piece of data, or this or may need more evidence or more research done in order to make sure that the piece of evidence you've collected is in fact supporting or rejecting your research question. And how well does the evidence as a whole answer your research question? Good luck.